AP Statistics Confidence Intervals by Jaycelin, Kevin, and David Sagatelian.
Today we are going to discuss confidence intervals and then go over a few examples. Here's the first example.
Example 1. A manufacturer of high-resolution video terminals must control the tension of the mesh of fine wires that lie behind the surface of the viewing screen. Too much tension will tear the mesh and too little will allow wrinkles. The tension is measured by an electrical device with output readings in millivolts, MV. Some variation is inherent in the production process. Careful study has shown that when the process is operating properly, the standard deviation of the tension reading is standard deviation equals 43 millivolts. Here are the tension readings from SRS of 20 screens from a single day's production.
Here is the data: 269.5, 297.0, 269.6, 283.3, 304.8, 280.4, 233.5, 257.4, 317.5, 327.4, 264.7, 307.7, 310.0, 343.3, 328.1, 342.6, 338.8, 340.1, 374.6, 336.1.
Here's the problem. Construct a 90% confidence interval for the mean tension mu of all the screens produced on this day.
Steps to complete this problem. Step number 1. Identify the population of interest and the parameter you want to draw a conclusion about. In this case, the population of interest is all video terminals produced in a single day. You also want to estimate mu, which is the mean tension for all of these screens. Step number 2. Choose appropriate inference procedure. Since we know standard deviation, we can use the confidence interval for a population mean that is used to estimate mu. We also have to make sure the two conditions are met.
Step 2 continued. To make sure the distribution is normal, we need to make stand plot of the data. As you can see, the data is fairly normal.
Once the conditions are met, we can carry out the inference procedure. The mean tension reading for 20 screens in our sample is 306.3 millivolts. You get this number by adding all the data and dividing it by 20. Step 3 continued. The confidence interval formula is x bar plus or minus the z-score times the standard deviation over the square root of n. So 306.3 plus or minus 1.645 times 43 over the square root of 20, which equals 306.3 plus or minus 15.8, which gives us the mean sample, which is 206.5 to 322.1.
If you were wondering how we got z-score equals 1.645, look at table C at the 90% z-score.
It's on the last row, 4 columns over. Step number 4, interpret the data. After you correctly do the math, you get 290.5 and 322.1. So what does this mean? It means that we are 90% confident that the true mean tension in the entire batch of video terminals produced that day is between 290.5 and 322.1 millivolts.
In case you forget, here is the inference toolbox for confidence intervals. To construct a confidence interval, step number 1, identify the population of interest and the parameter you want to draw conclusions about.
Step 2. Choose the appropriate inference procedure. Verify the conditions for using the selected procedure. Step 3. If the conditions are met, carry out the inference procedure. Confidence interval equals estimate plus or minus margin of error, z-score, times standard deviation divided by the square root of n. Step 4. Interpret your results in the context of the problem.
You can also use your TI-83. Step 1. Press stat. Choose test, then choose number 7, which is the interval. Pick the one that is shown on the picture right here.
Step 2. Adjust your setting by entering in the standard deviation, list 1, which contains all your data and your desired confidence interval. Example 95%. Step 3. Press calculate. It then gives you the z interval as well as the population and sample mean.
The end.